Hello, beautiful people. I'm going to be covering lesson 3.1 and lesson 3.2. So, if you have already gone over 3.1 with me in class, then you're going to want to go ahead and skip ahead of this video until you get to lesson 3.2. So, it is going to be longer, but that's only if you have not done 3.1 with me. And again, let's say we left off on example 2. You're going to want to skip ahead until you get to example 2, unless you just want a refresh of what we have talked about in class. Okay, so a sequence is an ordered list, if I can spell correctly, an ordered list of numbers. Okay, so a recursive rule for a sequence is going to give you two things. First thing it's going to give you is the starting value. So where are we beginning? And then it's going to give you a rule of some sort, either what you're adding, what you're subtracting, what you're multiplying, a pattern. Okay, so a rule, so think of it as the pattern. Okay, and that tells us how we're going to get the next value if we know what the previous value is. So, a better way that I can explain this, why are we doing it in words and why are we doing it with math? Okay, a lot of us are lazy, right? I will even admit that I am lazy. So instead of having to rewrite every single time the in words portion, I meant to do a highlighter. Instead of having to write this all out every single time in words, that is why we're going to use our math notation, right? We're going to take a shortcut and use the math notation to write out the rule instead of having to do it with words every time. So just think, let's not be lazy, let's be cool and use the the notation. We're going to basically just substitute, like if my full name is Gabriella, people call me Gabby, it's my nickname, right? So, start with the number -5. Okay, well, remember in class we said u sub 1, that's the first term. Okay, we're given the first term and it's -5. Okay, so u1 is equal to 5. And let's put that off to the side here. u1 is equal to the first number. Okay, the second part of the rule, this is number 1, this is number 1. Then we have a second part of the rule. It says to get the next number, you're going to add 3 to the previous number. Okay, well, if I have the next number, we're just going to call it n, right? U sub n, or un, is going to be equal to the previous number. Well, how do I get the previous number? I'm going to subtract 1. So un minus 1. So the next number is equal to the previous, and it tells us to add 3. So we're going to plus 3. Okay, to make the n's and the n minus 1 make more sense, okay? If I'm starting with -5 and it tells me to add 3, right? I am going to get u2. So u1, u2, we want to get the next 5 terms, u4, u5. Okay, I'm going to give us an example. Okay, if I started at 6, and then I said this was 5, this was 4, this was 3, this was 2, right? I'm subtracting 1. That's basically what we're saying, is we're taking the next number and we're going to subtract 1 from it. Okay, so if I know that u sub 3 is going to be equal to, let's see, this was -5. We're going to add 3. This is going to be -2, 1, 4, and 7. If I was to know that u sub 3, okay, I'm going to take the second term and I'm going to add 3 to it. Well, if you look here, this is the next number, and then this is the previous number, so we subtract 1 from it. Same thing, you do that every single time. If I know the 10th number, then I'm going to look at the 9th number and I'm going to add 3 to it. If I know the 20th number, okay, I'm going to look at the 19th number. and I'm going to add 3 to it. So that's why we have the n minus 1 and the n. Okay, so that's all for example 1. Example 2, we're starting with the number 10. So again, we're starting with the first term of 10. Okay, and then let's go ahead and put that off to the side again. U1 is equal to the first number. So if I had U5, that would be the 5th number. If I had U20, that would be the 20th number. Okay, the second part is to get the next number, we're going to subtract 7 away from the previous. So we're going to have our next numbers equal to the previous minus 7. So again, UN is equal to the next number. And UN minus 1 is equal to the previous number. So you can even say it like this. You can say, but again, this is a little, we want to be lazy. We want to shorten this up. The next is equal to the previous minus 7. So this is the same thing as this. This is the same thing as this. Okay. And again, we're looking to find U1, U2, U3, U4, and U5. So we're looking to find the first, the second, the fourth, and the 5th number in this sequence. So we already know that U1 is going to be 10, and we're subtracting 7. So 3, -4, -11, and -18. Okay. Next, example 2, we're going to be given the shortcut. Now we got to write it in words, okay? So, and then we're going to find the values, first term, second term, and third term. Oh, look at there. We now have U0. Well, it is the same exact thing, but now this is just the 0 term. So the 0 term is equal to -4. Okay? Well, what's happening now? It's the next is equal to the previous plus 9. Well, that means I'm going to be adding 9 each time. So to get the next number or next term, add 9 to the previous. So -4 plus 9 is going to be 5. 5 plus 9 is going to be 14. 14 plus 9 is going to be 23. So we got U0, the 0 term. We have the first term, second term, and third term. Okay. U0 is equal to 80. So the 0 term is 80. And again, like I told you guys before, you'll know based on the context of the problem if you're going to use U1 or U0. All right. We have the next is equal to 1/4 times the previous. Okay. You need to recognize this as multiplication, right? Basically, if there's parentheses there, you can show it just by putting it next to each other since we have a variable there. So this is 1/4 times the previous. So to get the next term, multiply 1/4 to get the previous. Wait, to get the, multiply 1/4 to the previous number. So 80 times 1/4 is going to be 20. 20 times 1/4 is going to be 5. And then 5 times 1/4 is going to be 5/4. But if you put that as a decimal, that's going to be 5 divided by 4, which is equal to 1.25. Okay. So example 3, write out the math notation for each sequence. Then use your rule to find the 10th term of the sequence. So we're going to find the 10th term. So note in the sequence, the starting term is use of 1. So all of these are starting by use of 1. So we can just go ahead and write use of 1 is equal to something. Well, look here. It's that first term, 2.5. What's the next part of the rule? It's going to be the next is equal to the previous plus, minus, or times something. So u sub n is equal to u sub n minus 1. And I go from 2.5 to 5 to 7.5 to 10. I can see here that I'm adding 2.5 each time. I'm adding 2.5 each time. Okay? Now, to get the 10th term, we could go ahead and make a table. That is perfectly fine to make a table. Okay? And I'll show you both ways. I'll make a table small down here. So if we already know that this is U1, U2, U3, U4, let's go ahead and start at the term. And then let's go ahead and put the value. Okay. So we already know, I'm just going to start at the 4th term. And then we're going to find 5, 6, 7, 8, 9, and 10. Okay. So u sub 4 was 10. And again, I'm adding 2.5 each time. So 12.5, 15, 17.5, 20, 22.5, and 25. That is one way to go about it. You're just going to keep going and going and going and going and going. This will get you the correct answer. Okay. Now, but if you like to just go quickly, because sometimes maybe we're going to go past the 10th term, right? We want to find u sub 10. Okay. Where are we starting? This is the start. Let's just start from where we're given. U sub 1, that's 2.5. Okay. Plus, how much are we adding each time? We're adding 2.5, right? And we're going to add 2.5 until we get to 10, like 10 times, right? So it's going to be, plus 2.5, plus 2.5, plus 2.5, plus dot, 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 right? That's what we did here on the table. But if I want to shorten that up, okay, this is the pattern right here. What is the same thing as repeated addition? It's multiplication. So let's go ahead and put in the parentheses what we're going to multiply by. So if we're starting at 1, okay, we're starting at 1, u sub 1. We're starting at u sub 1, and we want to get to u sub 10. How many are we adding in between? Well, we need to add it 9 times. Okay? So we're going to have 9 groups of 2.5. So we're going to multiply. So 2.5 times 9. It's going to give us 22.5, and then we add the 2.5 at the end. So we're going to do this, and I'm going to kind of put it off. I know it's kind of hard to see. But that right there is equal to 22.5, and we still have the plus 2.5. And that is how we get 25 as well. Okay? So for the other example, I'm just going to do the expression part for the next example. Okay? So again, you can make a table or you can go ahead and do the expression. So we have 4, then we go 8, then 16, then 32. Well, I know my u sub 1 is going to be equal to my first term, which is 4. What is my pattern here? Where I'm not adding the same thing, I'm not subtracting the same thing, I'm multiplying by 2. So u sub n is equal to u sub n minus 1 times 2. You could have the 2 at the front if you like it at the front, like this. You can put the little dot for multiplication. It's the same thing. So for the 10th value, so we want u sub 10 is equal to, where are we starting? We're starting at 4. Okay? Plus, okay? I mean, not plus, sorry. Times. We're timesing by 2. Okay? This is the pattern. We're timesing by 2, or the rule, right? In parentheses, How many times am I multiplying 2? Again, we're at u sub 1, and we want to get to u10. So how many times am I going to do that? I'm going to do that 9 times. So is it 4 times 2 times 9? Or is it times 2 times 2? I'm multiplying by 2. Okay? Repeated multiplication should be written as an exponent. So the 9 is actually going to be up there. So if you do 2 to the 9th times 4, okay, I'm going to go ahead and put that in the calculator. 2 to the 9th power. That is going to give me 512. This right here is 512. But we still have to multiply by 4. And we get 2048. Let's double check with the table. So again, I'm going to start at the fourth term. Fourth term was equal to 32. 5, 6, 7, 8, 9, and 10. We should get 2048. So 32 times 2 is 64. 64 times 2 is 128. 128 times 2 is 256. 256 times 8 is going to be 512. Hold on, did I mess up a little bit? 128. Ooh. 128 times 2 times 2 times 2 is 1,024 times 2 is 2,048. Ooh. We are correct. I was just double checking my math. Okay, so again, table works. Table does work, but if you're looking, if we wanted to know the 20th term value, right? U sub 20, then you would need to, it would take you a very long time. You would need to write out the expression. Okay, some babies gain an average of 1.5 pounds per month during the first 6 months after birth. Write a recursive rule. When you see recursive rule, know that you should be doing the U1 or the U0 and the UN minus 1. So recursive rule. I think you're going to be doing the things with the U's. U sub 1 or U sub 0, and then the U sub n minus 1, U sub n. Okay? Write a rule that gives the monthly weight of a baby weighing 6.8 pounds at birth. So how much does that baby weigh at birth? 6.8 pounds. This is where you need to decide. Am I going to do U sub 0? Am I looking at the 0 term? This is 0 month? Or am I looking at the first term, first month? Well, at birth, they're 0 months old. So we're going to be doing U sub 0. It's equal to 6.8. The second part of the rule is going to be the next term, or the next month, is equal to the previous term, the previous month, plus how much are they gaining on average? 1.5 pounds. So what's the baby's weight at month 5? Well, that's U5. It's equal to, okay, the previous plus 1.5. Again, we can do a table. That is fine. Let's see, where are we beginning? We are beginning at 6.8. And again, that is U0. We want to get to U5. Plus, what are we adding each time? The pattern, 1.5. How many times do we need to add it to get from U0 to U5? Oh, we're adding it 5 times. So do 1.5 times 5, which is 7.5, plus 6.8. You should get 14.3 pounds. If you do the multiplication first, which you should because of order of operations, you're going to do 1.5 times 5 and you're going to add 6.8. Okay, referring to the pattern, looking over here, we're going to write a recursive rule. We want to know how many boxes are in figure 10, and we want to know which figure number will have 41 boxes. Okay, figure 1 has 3, figure 2 has 5, figure 3 has 7. So looking over here, u sub 1, because I'm starting with figure 1, is equal to 3. U sub n is equal to u sub n minus 1. How is this changing? What is the pattern here? The pattern is it's adding 2. So plus 2. If I want to know how many boxes are in figure 10, I'm going to look at U10. That is going to be equal to where we started, 3 plus our pattern. Again, this is where we start. Here's our pattern. How many times do I need to add 2 to itself if I'm starting at u sub 1 and I want to get to u sub 10? How many times do I add it? Oh, I add it 9 times. So I'm going to be adding it 2 plus 2 plus 2 plus 2 plus 9 times. That didn't even, my words just jump together. Okay, 2 times 9 is 18. What's 18 plus 3? 21. So there's going to be 21 boxes in figure 10. Okay, well, let's go backwards. Now we want to know what figure number will have 41 boxes. Okay, so now we're going to say, okay, there's 41 boxes total, right? We can continue the table. In this case, I think it's going to be easier. We know in u sub 10, there's 21. Then we're adding 3 each time. We're adding 2, sorry. So 23. Let's keep going until we get to 41. 27. 29. 31. 33. 35. 37. 39. And 41. So in figure 20, there's going to be 41 boxes. Okay? Figure 20, there's going to be 41 boxes. Okay, so now we are going to move on to section 3.2. Remember, I will be checking both notes tomorrow in class. Okay, section 3.2 is going to help you with the questions number 6, 7, and 8. So here's your guys' homework. Ignore the blue scribbles, okay? But section 3.1, what I just finished, is going to cover number 1 through 5. Section 3.2 is going to cover 6, 7, and 8. So first thing we're going to do is we're just going to review some solving equations, okay? I'm going to be reviewing a lot of these more in class, and I want to give you guys another method to go about solving these problems, okay? So we have 14 plus 3 times x minus 5 is equal to 8. Over here on the side, we're going to go ahead and set up a table. This is called, we're going to have this side being the order, and this side is going to be the solve. So basically, we're going from top to bottom, and here we're going to go from bottom to top. The first thing that we start with is x. What is the first thing that is happening to this x? We can see here in the parentheses, the first thing that's happening is it is being subtracted by 5. You see that? It's being subtracted by 5. Okay. The second thing that's happening, after we subtract by 5, oh, look, it's going to be multiplied by 3. After we multiply by 3, what's happening? We're adding 14. So the first thing we do, we go from top to bottom. We're going to do the inverse operation, the undoing, the opposite operation. So instead of adding 14, we're going to subtract 14. So go ahead and subtract 14 from both sides of the equal sign. So we have 3 times x minus 5 is equal to negative 6. And I want to still see you doing both. If you're doing the table, you need to make sure you're showing your work. You don't have to do the table, but do the table if it helps. What is the inverse of multiplying by 3? It is dividing by 3. So now you're going to divide both sides by 3. That cancels out to 1. So you're left with x minus 5 is equal to negative 2. The last thing that's happening is we're subtracting 5. The opposite of subtracting 5, the inverse, is adding 5. So add 5 to both sides. X is equal to 3. So each time that I'm explaining these problems now in class, I'm going to go ahead and do the table on the side. Again, you go from top to bottom, what's happening with x first, and then you do the opposite to get your answer. Okay, so we're going to fill in the table of values of the points in each of the graphs. Then we're going to write a recursive rule. So this is super, super simple. Let's just go ahead and start with our points. We're going to look at them from left to right. So starting with the x values, this first point here, that point has an x value of 0 and a y value of 4. The next one, this is 1, this is 2, 3, 4, right? The next one has an x value of 1 and a y value of 3. Then we have an x value of 2, y value of 2. Then we have an x value of 3 and a y value of 1. Then the last point has an x value of 4 and a y value of 0. So again, we're starting from left to right. So if we look here, we're given the 0 term. So it's going to be u sub 0 is equal to what? It's equal to 4. Okay? U sub n is equal to, well, what is this side? What's happening? What's the pattern? Oh, it's subtracting 1, subtracting 1, subtracting 1, subtracting 1. And then this side is up by 1. So our pattern is negative 1, 1. So it's just going to be u sub n minus 1, and we're subtracting 1. So that's going to be our recursive rule. Okay, looking at this side, okay, right here, we're right in the middle. X value is 0. The y value is negative 1.5. Okay. X value is 1, and we have 0. X value is 2, and we're at 1.5. X value is 3, and we are at 3. So what is our pattern here? I'm adding 1.5, 1.5. And we started at the 0 term at negative 1.5. So un is equal to un minus 1 plus 1.5. So you're literally just taking those points on the table, plotting them on the table, and looking at your pattern. Okay, you walk into an elevator in the basement of a building. A control panel displays 0 for the floor number. The table shows the floor numbers and their digits in relation to the ground level. So write a recursive rule that gives the height in relation to ground level based on the floor. So we're starting with the 0 term. So u sub 0 is equal to negative 4. Well, what is this adding each time? Or what is the relationship here? Well, from negative 4 to all the way to positive 9, I have to first add 4 to get to 0 and then plus 9. So 4 plus 9 is going to be 13. So I'm adding 13 to get the next number. So the next number is equal to the previous plus 13. We're going to go ahead and plot the points